Okay, so now let's spend some time to discuss about different types of linear programs. Okay, in particular here we're going to tell you that for linear programs there are some categories, and it's important to know whether each linear program belongs to this category or that category. So what we're saying here is that there are three different categories. An LP may be either infeasible or unbounded or finitely optimal. It must belong to either one of these three. Cannot be two, cannot be zero. Okay? For finitely optimal, here we mean there is an optimal solution. For infeasible, that means there is no feasible solution. And for unbounded, that means there are feasible solutions, but there is no optimal solution. We're going to see the details later. Also, a finitely optimal linear program may be one of the following situations. There may be a unique optimal solution, or there may be multiple optimal solutions. But typically, what's more important is to distinguish between these three situations: infeasible, unbounded, and finitely optimal. We don't really care too much about the case with multiple optimal solutions, because typically what we really want is just one optimal solution. So an LP is infeasible if the feasible region is empty or if there is no feasible solution. Simple. So for this example, there are three constraints, and all the constraints together conflicting with each other. Okay, there is no intersection of those three separated feasible regions, and that's why the feasible region is empty. Okay, you have the graph and you may do a verification. A linear program may be unbounded if the following things happens. For any feasible solution, there is another feasible solution that is better. Okay, consider this example. There are two constraints, so the feasible region is the right hand side part, and it goes to infinity. Okay, also we want to maximize x1 plus x2, so it's definitely true that given any solution, there is a better solution as long as you make x1 and x2 larger. Okay, or if you look at the graph here, you draw one isoprofit line, or let's call it isoprofit line, and then you can see that this direction that you want to push to is unbounded. Okay, you have an unbounded improving direction, and that's why this LP is unbounded. There's one important thing to know, that an unbounded feasible region certainly does not imply an unbounded linear program. Okay, this is exactly the same feasible region as in the previous slides, but here if we change the objective to be minimizing x1 plus x2, then there is a unique optimal solution. Okay, so unbounded feasible region does not imply unbounded LP. Maybe you want to think about the following questions. Does unbounded LP implies unbounded feasible region, or is this condition necessary? Is an unbounded feasible region necessary for unbounded LP? Okay, think about that by yourself. If a linear program is either infeasible or unbounded, we say it is finitely optimal. It is not infeasible, so there are some feasible solutions, and it is not unbounded, so there is at least one optimal solution, and that's why we call it finitely optimal. Okay, it's possible that there are multiple optimal solutions. For example, in this particular example, we can see that all the points on this line segment is optimal. Okay, but in that case, we only want to find one optimal solution, so we don't really care about how to find all of them. That's not really something important, right? When we are making decisions, okay, to make products or to decide routes or to decide what to buy, we only want to execute one plan and that's why we only want to find one optimal solution. Here, one thing we observe is that the slope for the objective function and one constraint is identical, and that's why you can see that there's one isopropyl line that will intersect with the constraint or the edge, okay, at a line segment. The question is that if the slope of the isoquant line is identical to one of the constraints, will that always give us a multiple optimal solutions? That means if you have identical slopes for constraints and the objective functions, do you always have multiple optimal solutions? Okay, challenge yourself by thinking about this. So either infeasible or feasible, right? Because either you have no feasible solution or there are some. If there are some, then you worry about whether there is an optimal solution or no. Okay, so if we say an LP has no optimal solution, it's either infeasible or unbounded. If there is an optimal solution, then it may be unique or there may be multiple optimal solutions. Here, I use dashed lines here because this distinction is not very important in practice. Okay, in practice we care about to distinguish whether an LP is infeasible, unbounded, or finitely optimal. That's more important. Okay, so as we mentioned again and again, we only want to find one optimal solution because we only want to make one optimal decision. Okay, so keep in mind there are three different types of linear programs. When we develop methods to solve general linear programs, we need to be able to take care of all the three possibilities in one method. Okay, that's some challenges and that's some topics in the next lecture.